So thanks a lot. As mentioned, I'm CEO of SESAMm, and we're a company dealing with natural language processing technologies. This is not meant to be a sales presentation or anything like that. It is meant to be a high-level technical description of architectures that we use for natural language processing engine and how we believe there are better ways to address natural language processing use cases in the field of investment for both quantitative and fundamental funds. And the reason for that is that we meet with a lot of clients and prospects that are really by themselves developing a lot of NLP use cases internally, and they're doing this on a regular basis. They're doing that in order to track, for example, employee reviews or consumer reviews. They're doing that to track machine-readable news, and they're doing a lot of different use cases. And the main priority right now that we see for clients is moving from experimentation to production and being able to start scaling these different use cases that have been created. So what I'll show you today is an example of the development of a scalable NLP system and how we apply it to different use cases and how we thought about having an engine that is more than just targeting one use case, but that is able to address various types of data sets and various types of investment use cases across different asset classes. Oh, and this doesn't work. Yeah. Okay. Okay, so just a few words about the company. SESAMm has been created in 2014. We're a 40 people company, and we work mostly on natural language processing technologies and machine learning technologies. Our goal is to understand public web information. So anything that is related to news, blog discussions, social media, we try to track and try to understand it so as to provide good insights to investors that are using our solutions. We're based in France, as you may hear, and have also offices in New York and Tunisia. So we've been in this business for quite some time, and in total we had the opportunity to address around 30 different client use cases, some that are very different from one another, including, as I mentioned, employee reviews, for example, analyzing Glassdoor data, machine-readable news, analyzing Dow Jones DNA data, analyzing Twitter data. So we've been able to really target a lot of use cases as an NLP team inside a large asset manager or hedge fund would do. So we have that same expertise that teams are developing internally, and we are really focusing only on that in order to serve our clients. So the first thing that I want to tell you about is some of the challenges that we observe right now in NLP for investment. The main and first challenge that we see is that most firms are considering NLP task as a dataset by dataset use case, meaning that a firm would buy a specific dataset for one specific use case and use only that dataset without cross-referencing it with other datasets in order to address their team. Typical use case is we are buying a specific dataset related to products based on Amazon reviews. That dataset will be used only for one specific use case and will not be used otherwise. This very much limits the breadth of analysis that can be done, and this very much focuses on short-term wins rather than a long-term NLP strategy for the entire company. The second thing that we see, and that is that we see more inside quant teams, is sometimes neglecting the retraining of open source models that are available on the web. A lot of quants that we talk to tends to consider NLP technologies as they would more traditional quant algorithm that provide some kind of ground truth. NLP technologies and trained algorithms, for example, for sentiment analysis, do not provide ground truth. They provide a specific task based on the underlying gold data sets that has been used in order to provide the training. And it is very important to consider that these data sets will likely have to be retrained before being leveraged in any kind of application for investment purposes. Use cases are addressed for several data sets. Let's say that we're developing, for example, a sentiment analysis that is dedicated to Glassdoor data, so employee reviews. That sentiment analysis algorithm is in some cases developed specifically for that use case and is not generalized in order to be applied to Amazon reviews, as I mentioned after. And this is really a problem that we also observe, the lack of generalization of these use cases. And finally, I'm sure that you're aware, if you've been working on NLP use cases, this is still a phase of POCs and experimentation, meaning that results have to be delivered very quickly. The teams do not necessarily have the time to focus on generalizing the system, on building a more global engine. So there's a lack of standardization, and these use cases actually tend to not scale so well when volumes of data increase. If you're tracking a company using web data and then suddenly have to scale for 1,000 different companies in order to cover your whole portfolio, the architecture that you have implemented for the first company is likely not the one that you will use for all companies. So these are some of the challenges that we see every single day when we talk with clients, and that is really due to the fact that these NLP data science teams that are constructed inside hedge funds are very operational teams that are meant to serve portfolio managers in many cases, and that therefore do not necessarily have that time to build a more global system. Hopefully some solutions actually exist, and we've been able to gather some best practices and also to make recommendations to some of our clients that are moving in that direction. Some of the solution related to text is focusing not on the data source, but focusing on the portfolio itself and trying to aggregate a data lake, a text data lake for which NLP task will be used that is actually representing your portfolio well, rather than only focusing on one specific type of data set that you could acquire from a data provider. That is very important, because the goal of alternative data and NLP task in the context of trying to generate alpha is to better understand the companies or other assets in your portfolio. And so the goal is not to focus on the data source, but to focus on the use case and on that understanding. There's also the need to control and retrain open source models, centralized algorithm, I mentioned that before, standardized code development. That is quite a complex task, and that is mostly due, in our opinion, to the type of people that work in these teams. We see a lot of data scientists, formerly quants in many cases actually, that are working in these teams, and a lack of software engineers, big data engineers or data engineers. We very much recommend that at least a few software engineers are included in these teams if the goal is to move from use cases approach to a more generic system, because that will help code properly and have a system that can actually scale for more use cases. And that actually generates constraints. The requirements to do that are at least 2 to 3 years of work in order to do things properly internally, a real budget, and a dedicated team that does not have to perform short-term use cases at the same time as needing to generalize and standardize their technology. So there's still something that we identify as a pain. We see hedge funds that are really advanced and that have been able to build these kinds of central NLP team that then serve all of the portfolio managers and all of the different teams. But for a lot of other firms, it still is something that is very complex, and these data science or NLP team still are POC oriented and use case oriented operational teams that work directly for short-term use cases for portfolio managers. So the good thing is at SESAMm we had the opportunity to do that because that is our only focus. We're not managing assets, we're delivering software solutions and alternative data. So I want to tell you a bit more about how we did that and what are the specificity of the architectures that we implemented in order to perform these tasks. So the first thing is we thought in terms of platform. We developed a platform called Text Reveal that includes a global data lake, allowing us to serve a lot of different use cases in public and also in private market, and that could cover basically any investor portfolio without having to acquire additional data sets. And so we built a data lake and included the constraints of being able to run analytics on that live data lake and historical data lake. And the total data lake is right now a size of 8 billion articles and documents. It contains more than 2 million different data sources, and we try to include a bit of everything, not only machine-readable news that is purely financial sourced from Refinitiv or Dow Jones, for example, but also consumer-oriented data from blogs or consumer discussions, and also social media and social trading information. We don't have an exhaustive data set for every single category of source, but at least we have information for every single asset that we can basically analyze. The second thing that we needed is to build a system in order to make sense of the data lake and to help clients filter the right information for these use cases. What we build internally is a knowledge graph. A knowledge graph is basically a system that helps you link various entities, for example, a company with its brands, products, or C-level executives. And this knowledge graph allows two things. It first allows to bring additional recall to the algorithm and in terms of filtering, meaning trying to get more data than just doing a full text search of the name of the company. And in addition to that, it can increase precision by cross-referencing products and the name of the company, so as to make sure that we are indeed identifying the right product that is linked to the mother company that we wish to analyze. I'll give you a more concrete use case. Typically, if we're analyzing Apple as a company, we would like to automatically get information about all of Apple's products and all of Apple's brands and Apple's CEO and chairman, etc., etc. If we're missing that information, it means that we're missing probably more than 90% of all of the information that is available on Apple, and we're very likely missing almost everything that is consumer-oriented data. And that's too bad, because Apple is very much a consumer-oriented company, and therefore we would miss what may have the main impact on market price. And so in order to access that information, our knowledge graph will link Apple to its products, such as the iPhone 7 or iPhone 10, etc., its brand and its subsidiary, its CEO, etc., etc. So that is a quite important task, and we believe in the logic of building a global natural language processing engine, it may be the hardest and the most important task. Because having a very large data lake is basically a matter for sourcing the right data sources and acquiring them. Having good sentiment analysis algorithm is a very focused task that can be addressed with a team of data scientists. Being able to filter the right data for each individual use case is what will actually bring value to the time series. If you have data that is basically not interesting, or that where you're lacking a lot of information that you should include in your time series, the end time series will likely not be very interesting. Once the knowledge graph is in place, we're able to filter information. We're able, from that data lake, to find the articles and messages that are most relevant to our use case. And also we give some flexibility to users in order to make some of these choices by themselves. And once we have that, we have a lot of different predictors, such as sentiment analysis algorithm, or emotions analysis algorithm, or language biases algorithm, which are used in order to create these final time series that can be used in a quantitative or a fundamental use case. And finally, we need to make sure that we are able to deliver that information in different ways. If you're a global asset manager, you may have teams that are both quantitative and fundamental, and it is good to have a system that can serve both purposes, meaning being able to deliver both dashboards and time series in API or flat files. So all of these constraints really have to be taken into account in order to build a system that can address needs not only in the short term, but also in the long term. And when I'm talking about knowledge graph, for example, on companies, etc., there are a lot of additional specificities. For example, being able to track a knowledge graph on countries for fixed income, or specifically to be able to include corporate bonds level information inside that knowledge graph, so as to differentiate between equity and corporate bonds. So all of that information needs to be included based on the global portfolio of your team, or preferably of your company, in order to develop the right algorithm in the right way. So I want to tell you a bit more about the architecture itself, and this is really our example, but we've been quite successful in that domain, and we've had a lot of very good client feedback on that architecture and how it serves their needs. So it is not an absolute recommendation and the perfect solution, but it is something that we have been able to achieve, and that is therefore achievable and useful for clients. So the way our system works is that it is all based on the user request. It's basically an API request with a Python wrapper, where clients can input the information that will help them compute the right time series or display the right information. The end goal, you'll see, is to either get a time series for a quant firm, or to display underlying text, or to display information in a dashboard directly, and to get some BI analytics for a fundamental team. So the user request is basically composed of a lot of different inputs. That can be, I am looking for information related to consumers only. I'm looking for that information only in the Asia zone, in China and Japan. I would like that information to then be processed using sentiment analysis, and I would like that information on these 50 different companies, and please use indeed the knowledge graph in order to make sure that you have the underlying products and brands of these companies. So this is basically a user request, a set of inputs that are meant to be as generic as possible, so as to not block the user, and so as to not impose a specific technical solution and one time series for everyone, but that is generic enough so that different parts of the team and different types of assets can be covered with these technologies. The second aspect is knowledge graph, as I mentioned. The third aspect is using the knowledge graph that helps us include more keywords in our request, find these keywords and disambiguate them in our data lake. I'll talk to you about this in a moment. Name entity recognition and entity linking, meaning trying to perform disambiguation task, identify the fact that a specific keyword is a company and therefore closest to what you're looking for, and then actually relating that keyword that you found in one specific article directly to the description that you have for that entity in your knowledge graph. That is one of the hardest tasks in our opinion. It is not necessarily as critical as the knowledge graph because it can be addressed manually to some extent, but it is one of the hardest tasks from a technology perspective, being able to say that basically Apple the fruit and Apple the company are two different things and allowing the algorithm to find that difference. We then go into filtered data once we have been able to find the right information through the knowledge graph in the data lake and to disambiguate that information. We get filtered information and we apply our predictors. So as I mentioned, for example, sentiment analysis predictors. And to do that, we use a lot of embeddings techniques in order to get some context around the text that we are analyzing, generally speaking. I'll tell you a bit more about this. And once we have that, we're able to basically display final score and to get a final output for the user, be it a fundamental or quantitative team. So I want to tell you just a bit more about the knowledge graph and how we see the knowledge graph as something that is both interesting and in some cases potentially dangerous and therefore has to be controlled very, very precisely. So some of the challenges that we encountered. So for us, the knowledge graph is a mean to expand the set of keywords. You're looking for a company but do not wish to manually input all of the underlying information related to that company. You're looking for an emerging country, for example, and do not wish to describe the whole political scene of that country in order to have relevant information on it. That is information that is included as keywords, as entities that are point in time inside the knowledge graph. Why I'm mentioning point in time, I think there was a question. All right, yeah. Why I'm mentioning point in time is because these entities inside the knowledge graph tend to change very quickly. The CEO of the company now is not necessarily the CEO of the company tomorrow, and the president of one of the emerging countries that we're tracking will probably change in the next few years. So that information needs also to be included in the point in time quite early on, and this is a quite challenging task. So the knowledge graph will help us get a lot more information. It will help us increase recall in our request. The problem of the knowledge graph is handling the balance between that recall that we're creating and the precision that is ultimately needed in order to compute the final time series. This is addressed using the disambiguation algorithm, which will help us refilter the data and exclude anything that is not precisely in the context that we are looking for. So the knowledge graph is very important. It will help you find the relevant information, but at the same time, it should be properly controlled using disambiguation algorithm and entity linking algorithm. Otherwise, you will get a lot of garbage in, garbage out. Another part I wanted to mention is the embeddings, which I believe are right now one of the most important type of algorithm and technology in natural language processing. So embeddings are basically a way to represent text as vectors and as numbers and are used in a range of applications from simply being used as inputs of supervised machine learning systems. Taking the example of, let's say you want to detect a specific investment theme in a specific article. This is a supervised learning task. You have 6 different categories and you want to classify that. In order to perform that task, it is very useful to include embeddings as inputs of your system so as to enrich the context of your algorithm. But embeddings is often used in other contexts so as to identify distances between different contexts. For example, if you're tracking an ESG factor and meaning to create an indicator related to the environment, deep embeddings are a very good way to track the concept of environment and to then link all articles and messages that are related to that concept. The interesting part of embeddings is that it is not purely supervised machine learning, meaning that you can leverage a very, very large data lake and not have that systematic process of having an annotated database in order to leverage your algorithm. So we believe this is really, a lot of companies are moving in that space, but for investment too, we believe this is really the future to work on embeddings, and especially deep embeddings such as BERT, that is the system that have been released by Google and that we leverage internally. BERT large and BERT small for those that know that. So embeddings really as part of this system allow us to get more context, to augment the precision of our algorithm, and to solve some tasks much more easily than if we had to go through supervised machine learning techniques every single time. So I gave you a brief description of the architecture and how we see a request being performed by a user. And this has been very, very generic, as you saw. Any PM that is requesting information and that would use natural language processing in order to get an answer to that question can go through these same steps. It's agnostic from the type of asset class that you are tracking. It's agnostic from the type of data source that you are using. It's really something that is as generic as we can make it. And the way to make it generic, as I mentioned, is having a text data lake that is generic in itself, and also having a knowledge graph that is also as generic as possible. I want now to show you just a few examples, and most of these examples are created in just a few hours. And this is really the goal also of a team that means to be very agile, that means to solve a few use cases for portfolio managers, is to be able not to spend months redeveloping each individual use case, but to spend just a few hours to answer a specific question. So the first use case is very generic. You'll see this everywhere. We are looking to create a sentiment time series on a large number of assets, on all stocks in a portfolio, indices, commodities, currencies, anything that you want. This can be addressed directly with text reveal, and this can be addressed in a very simple way. We are looking for a time series related to an entity that can be tracked as just the ticker or just the company name. We don't have to recreate the sub-entities and to manually track the products and brands, etc. Everything is done automatically. And what we get is simply a set of time series for sentiment analysis, positive, negative, neutral, emotions analysis, so analyzing fear or surprise, for example, for any asset that we enter as input of text reveal. We are also able to leverage some of the filters that I mentioned. There's always metadata that has to be taken into account, filters by languages, filters by topics, etc., etc. So this is, I would say, use case 0 for any NLP team, is building sentiment analysis time series in order to track assets in a portfolio. This is usually use case number 2. We are looking to create ESG factors on a specific portfolio, in most cases on equities or indices directly. And we want to do that in a dynamic way. And why do we want to do that in a dynamic way? Because current ESG indices that we can track are providing very delayed information, where you get info about an environmental scandal a few months after it actually happens. And it is also a question of alpha decay. We want to create our own ESG time series simply because we don't believe that existing time series still provide any alpha. They are leveraged by everyone, and therefore they are completely used. And so the way we do that is we provide keywords related to the context of environmental, social, and government factors, such as, for example, pollution or waste management, etc. We let embeddings help us create a context around these keywords, and we then match articles that contain both these sets of context as described by embeddings and keywords that have been extracted by the knowledge graph. So in our former example of Apple, for example, anytime we get a message or an article that is related to one of the products of Apple that is contained in the knowledge graph, such as the iPhone 10. And on the other side, we see a context of environmental scandal, for example. We find that article, filter it, and use it as the base data lake for our ESG analysis on Apple. And what we can then do in these articles, they are a limited solution, but a very basic solution is simply to say, whenever we have an article that is positive and that is mentioning both Apple as a company and environmental context, we will decrease that ESG score. The good thing is, first, we can do that kind of weighting in any way that we want. We don't have to rely on an external factor. We can really build it by ourselves. And the second good thing is we can do it in real time. And so we can mix event-driven market impacts and ESG market impacts. So we can build these types of ESG factors every day, every hour, or every minute. And you see these types of alerts, for example, that we create in that context, daily alerts, created automatically, in this case, in around 2 hours, and that can be applied to every company. Okay, this is starting to be a bit more complex. This is asset allocation use case. We want to create a specific sentiment-like time series on macro factors. So macro factors are not well defined in the knowledge graph. If you're looking for something that is related, for example, to the European monetary policy, you have to start mixing several kinds of entities in order to construct a final time series. So this is what we do in that specific use case. We use text reveal with a bit more customization and with a specific matrix related to the client's the client's understood impact. The client is saying, okay, on monetary policies, here are the 15 factors that we actually want to track and that we believe has an impact. We identify them inside our knowledge graph and increase the vocabulary automatically. And we then create these kind of factors such as European monetary policy joy or US equity all fears, which are sentiment and emotions analysis factors based on these meta time series that we have constructed. In this case, we use these NLP factors and include them in predictive and quant models in order to create monthly asset allocation strategies on gov bonds and equities in Europe and in the US. And we also provide a lot of interpretation tools, explicability tools for clients so as to help them understand this specific monetary policy context that we track in financial news had that impact during that period on the allocation that is being proposed as part of the system. This is a use case that we have a lot right now because we see a lot of asset allocation teams are not performing these tasks fully systematically and wish to have an additional baseline for a systematic process. And so it's a good opportunity also to include new types of factors beyond market factors and fundamental factors to also include more global web-related factors. And I just wanted to show you a last short study. This is very, very up-to-date. It's a coronavirus study, basically, and the idea is very much the same as for ESG. We have the coronavirus that is a seed keyword that provides us with a risk context. Based on the coronavirus, we are able to use embeddings technologies in order to identify related keywords, and we do that in 23 languages so as to have a global worldwide coverage. On the other side, we have companies in our knowledge graph, such as LVMH, a French luxury company that has been heavily impacted by the outbreak of the coronavirus. And we wish to put these two items in relationship and see how we can basically quantify the impact of coronavirus on that company. And this is something that can be done at stock level, but also at country level, etc. How many times is that company mentioned in the context of coronavirus in earning calls, in public news, in consumers mentioning that they couldn't go to the Dior shop to buy the latest item because they were blocked due to the coronavirus. So all of that information is really useful in order to get a more quantitative assessment of the potential impact and before that actually has an impact on market price. So what we do here is we identify over the last 3 months in our data lake, we have around 70,000 mentions of LVMH as a company in the context of coronavirus. So people saying the latest Bulgari fashion show was cancelled due to coronavirus, for example. That kind of information is included. So it's quite significant in terms of information for around three months. And the global data lake that we leverage here helps us not have to buy a specific additional text data source in order to perform that study. We identify spikes that will track very, very closely in order to identify short-term market movements. So every time we have a very strong spike, we know that a lot of people are mentioning LVMH in the context of coronavirus. And this is the information that traders will look at in order to make a decision on that stock. We also identify other metadata information just to make sure that the data that we have is clean. Which are the languages, what are the main topics. For example, here we have topics related to style and fashion, media, finance. We know that we are in the right context to analyze LVMH as a company. And once we have that information, and this is again done very simply, it's around 2 hours, so it's fully automated. So it's a very, very simple use case. It's not anything that is custom. So once we have that, we simply track relative volumes of data of coronavirus plus the company versus just the company. And that gives us a percentage of impact of that company being mentioned in the context of coronavirus, which we then summarize as a global score. And that global score can serve as a baseline for an entire portfolio and can be used as an objective way to measure potential impact on a specific stock or an entire portfolio. And just so you know, here we included some of the articles and messages. This is also something I mentioned we need to take into account teams, not only quantitative teams, but also fundamental teams. One of the way that we consider the needs of fundamental teams and analysts is that we display the underlying data. So it's possible to click on any of these spikes and see the underlying articles and messages and actually read that information without having to spend too much time, because we can really filter the time period and focus only on what's important. So these are a lot of different use cases that I want to show you. I hope I haven't been too long. I didn't want to go too deep into the technical aspects, into types of algorithm that we use, etc. But it was more meant to share the journey on our side of building that global platform, and a journey that we believe a lot of hedge funds and asset management teams are currently trying to do by themselves. And we're here to help if we can, as we've been able to do that internally. Thank you.
I will permit some questions. Thank you very much, Sylvain.
Thanks.